Welcome back, grade 11s, and today we are going to be looking at one of the problems on Newton's laws, specifically Newton's second law. So one of the things that I mentioned in the previous video is that you are expected to know how to state these laws and also how to apply these laws. And so in this problem or example, which is one of the examples or problems that you will encounter in your test and exams, is we're given a box with a mass of 45 kg and we're told that it's being pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. So the best approach when it comes to solving these questions is it's best that you write down all your information separately on the side, right? And to also identify some of the forces that are acting on the object that you are presented with. So what I would do is that I'll first write down the mass of the object, which is 45 kg, and write down also the fact that since it's moving at a constant velocity, something that you should always remember is the acceleration, it's 0, right? And now we have to identify the forces. So before you even go through the questions that they've given to you, firstly, just identify the forces that are acting on this object. So we're told that it is on a horizontal surface. Right, you can see that it's on a horizontal surface. And so one of the forces that will always act on this object is the normal force, which will act perpendicular to the surface of the object. And the force that will oppose that is the gravitational force, which we call Fg. And we're told that this object is being pulled. And so you can see that it's being pulled to the right. And so, assuming that this is a rough surface, we can see that we can identify the frictional force as acting in the opposite direction. And something very important that you guys can't miss is, since this force, the applied force, is acting at an angle, it has components, the horizontal component and the vertical component, which will be very important when solving your question. So, before you can even go through the question, right? Firstly, let's just resolve the applied force that we have. So I'm gonna use a different colored pen, and so we can just draw a right angle triangle, and these are vectors. This is Fy, this is Fx, and we can call this theta, and this is 90 newtons, which is your hypotenuse. So from grade 8, I don't know if you remember the famous mnemonic, which is SOHCAHTOA. If you can't remember it, just remember this very important mnemonic that we use. So what I'm doing here is I'm trying to collect all my information so that it makes it easier for me to solve the problems, right? As you can see that we have not been given any problem, but I want to collect all my information. So looking for how we can find the horizontal component, which is Fy, we can see that this is sine theta and the opposite is Fy and the hypotenuse is 90, right? This is opposite over adjacent and our theta is equals to 50 degrees. So Fy is equals to 90 sine 50. And so let me just take out my calculator. So 90 sine 50 is equals to 68.94 newtons to the right, which is something very important that I see a lot of students miss, is that when given such problems, you also have to identify where your direction is. And in this case, if I choose right as positive, it means that my left will be negative. And to find the vertical component, which is Fx, right? So I don't have space, but okay. So that's cos theta is equals to Fx, which is the adjacent, all over 90. And Fx is equals to 90 cos 50, and that is equals to 90 cos 50, 57. I'm sorry, I think I made a mistake. This was supposed to be since this is the vertical component, I realized that I made a mistake. But yes, this is upwards, not to the right. This is upwards, not to the right. Excuse me for that. So yes, so what we've done here is that we've identified all the forces that are acting on the object. We've identified the frictional force, the normal force, the gravitational force. We've also identified the components that are acting on that object due to the applied force being at an angle. So here we are just expected to define the kinetic frictional force and Newton's first law of motion. Guys, this is easy marks, and you can literally just memorize the definitions and write them down. So one of the things that, I don't know if you guys have been told about this, but we have something called an examination guideline. And so as you can see here, it tells you what is expected from you, and it basically gives you a summary of the topics or the concepts that you've learned. And so since we are on Newton's laws and applications of Newton's laws, you are told the definitions, right? You're told the normal force, and it tells you the force. It's as the force or the component of the force which a surface exerts on an object. And all these definitions that they ask you, the kinetic frictional force, they're on the exam guideline. So go through the examination guideline. It has all the concepts, the summary of the concepts and the definitions that you have learned. So you are just expected to memorize and to state that all those terms. So the kinetic frictional force can be defined as the force that opposes the motion of the object relative to the surface, right? I'm not supposed to do this, but since you already know where you can find the definition. And 3.2, state Newton's first law of motion. Again, guys, easy, 2 marks. It states that an object will remain at rest, force of habit, or continue at a constant velocity unless a non-zero force acts on it. So please watch my first video where I explained these laws, but basically this is just easy 2 marks. What I was just doing here is just showing you that I just wanted to show you the examination guideline, that all these definitions are there. So just go through the examination guideline and you will be sorted. So this is one of the more where we are supposed to calculate the numerical part of Newton's laws, right? The first one, we were looking at the definition, and I mentioned that you should always refer to exam guideline. Obviously, you're not gonna have it with you when you're writing, but you have to memorize the definition based on the exam guideline, right? So remember when we were first presented with the problem, I said that you should always identify or look at what is happening to the object as you're presented with it. And I said that you should always identify the forces acting on the object. So think here, what I did here, when you do this, when you have the object as it is, this is called the force diagram, and this indicates all the forces on the object, but it is represented as the block that you have. One of the other ways that we use is something called a free body diagram, and the object is represented with a dot. This is a very powerful way to analyze what's happening to the object. So this is N, gravitational force, force applied, and the frictional force. So always, sometimes you're required to draw the free body diagram. In this problem, we just had to draw the force diagram. But always do this, always label the forces that are acting on an object, because it's gonna be very important when it comes to solving the problems, right, solving these problems. So it says that in the first problem, calculate the magnitude of the horizontal component of the applied force. We've already done this in the beginning when we were identifying everything, collecting all our information. We've already done this, but I'm just gonna do it again so that you guys it can be glued in how you can find the horizontal component. So cos theta is equals to fx all over 90, and fx is equals to 90 cos theta cos 50 degrees. That's 57.85 newtons to the right. Remember, direction is important. If it's a horizontal, it's either left or right. If it's horizontal, it's either upwards or downwards. So always write down the direction so that you can get your full 2 marks. The second one is calculate the magnitude of the normal force, right? And something that you guys should note is that the normal force doesn't have an equation. It doesn't have a set equation. You have to derive the equation for the normal force. So in most cases, it can be equal to the gravitational force Fg, but sometimes it can also be equals to maybe Fg minus F1 or something, right? This equation is not something that's necessarily set in stone. You have to derive. So if you're gonna just say, okay, every time they say calculate the normal force is equal to the gravitational force, you might be right, sometimes you might be wrong. You're just basically rolling the dice. So always note that you have to derive the equation for the normal force. So in our particular situation, we can see that the normal force is not necessarily equals to Fg, as I said. Remember, in most cases it can. In this case, if we had something like this, and maybe it's equals to this n is like this, and Fg, maybe there's a frictional force, and there's maybe just an applied force like this. It's horizontal, right? It's not at an angle. Then, yeah, Fg, Fg, n is equals to Fg. But not in this case because we have, remember, a vertical component, Fy. So, what is the equation? It's n, let's say upwards is positive, n plus Fy is equals to Fg. And Fg, remember, n plus Fy, horizontal component, is equals to mg. And n is equals, I like just writing it down like this first before I start putting my numbers, mg. So this is the mass times the gravitational acceleration. In case you're wondering, where does this mg come from? Like, did F become m? No, guys. So n now is equals to, what is the mass of our object we were given? It's equals to 45 times 9.8. Gravitational acceleration, it's in the data sheet, it's always equals to 9.8 minus Fy, the vertical component. Now the nice thing that we did in the beginning is that we did the work before we could even like start solving the problem. So you know what your horizontal component is equals to, which is 68.94. So let's go back, 68.94. So therefore, 45 times 9.8 minus 68.94. What is it equals to? Please verify wherever you are and like write it down on the comment section. Like, hey sir, I haven't really, nah. So that's our normal force. Remember, normal force doesn't have an equation set in time. No, you have to always derive the equation for the normal force. So we are told that we should calculate the coefficient of kinetic friction, which is nu k, right? So, okay, what are we supposed to do here, right? Coefficient of kinetic friction. Is there an equation for it? No, there is no equation specifically for the coefficient of kinetic friction per se. We can't really say that. But we know the equation for kinetic friction. It's Fk, so nu k times n. We know this, right? Therefore, for us to find nu k, we can just say Fk all over n. But what is Fk? Right, do you know the frictional force? No, we were not given the value for the frictional force. So what are we expected to do? So let's go back to the free body diagram that we derived. Remember, I said there is a vertical component. There is also a horizontal component, which we identified. And we did calculate the horizontal component, right? It's 57.85. So we're not necessarily doomed, you know. It's not that bad. So remember, let's go back to Fnet. I'm always gonna do this so that you guys remember Fnet is equal to ma. Since it's moving at a constant velocity, remember 0. And then what Fk is what? It's acting in what direction? To the left. So that means it's negative, and the horizontal component is to the right, meaning that it's positive. We identified the direction before. So fx minus fk is equals to 0. So what does that mean? Fk is therefore equals to fx. And we said it's what? 57. Let me just go back just to make sure. 0.85, guys. To the right. No, not to the right. Let's just do this. Well, it's to the left, but in this case, we're just looking for the value of fk. So we also have our normal force. We calculated it to be 3.72.06. So therefore, our new K is equals to 57.85, right? Frictional force, and 3.72.06. Therefore, what is it equals to? 57.85 times 372.06, 0.16. Or you can just say 0.155, but then yeah, it's 0.16. So yeah, this is basically it. So we had to derive, let me just we had to, because we're not given the frictional force, so we had to find what the frictional force is, and we used Newton's second law to do that. F net is equals to ma, and it just made it easier for us because the object is moving at a constant velocity. So let's look at the last question. Will the coefficient of kinetic friction change if the angle of the applied force is decreased? Yes or no? Well, let's look at this. What is the coefficient of friction? Remember, the definition of kinetic friction is the force that opposes the motion of the object relative to the surface. So it means that this coefficient is just only dependent on the surface of the object. The surface in which the object is on, not necessarily the object itself. So will that will the coefficient of, no, it will not. No, mu k depends on the surface in which the object acts upon. Alright guys, and that's it for me. Please remember that this thing is not really that difficult. You just have to always remember to identify your forces. Always remember to identify your forces before you can even get into the questions. Just don't be too quick to solve the questions. Just firstly, just plan out, okay, what's going on here. Identify, draw your force diagram, identify the forces that are acting on the object, the gravitational force, the normal force, and if, as you can see, this was acting at an angle, meaning that it has components, the vertical component and the horizontal component. And we assume that this is it's acting on a rough surface, so there is frictional force. So once you do that and you collect all your information, you write down your data, your mass, acceleration is equals to 0 because of constant velocity. It makes it easier for you to solve these problems. It's not really Mount Everest now. If you've identified everything before you even get into problems, then it becomes easier. And remember to always utilize the exam guideline. Just memorize the definitions that are in the exam guideline. And yeah, you'll be okay. So please, you can always come back to this. And yeah, please, it's me signing out. Thank you.